Hello, welcome to this class. Here we'll be looking at integration of trigonometry substitution and how do you identify if a particular integral question falls on the method of trigonometry by substitution. Okay, when your integral involve the following, if you have the integral of the square root. Okay, don't let me put it that way. When your integral involve the square root of a square minus x square, okay, you make use of, you say let x equal to a sine theta, okay, and if negativity is surrounding it, maybe there's a negative sign attached to the question apart from this, either front of the integral sign or in form of fraction, then since there's a negative sign attached to it, you let x equal to a cos theta, okay. And also when you have the question in form of the square root of a square plus x square, you say since it is plus in this case, you let x to be what? A tan theta. And also when you have the square root of x square minus a square, in this case, look at it, there's difference between this. The constant comes first here, and here the function x comes before the constant a. So in this case, you say let x equals a sec theta, okay. But why are we applying this? Why are we putting a? What is a? Why are we using this substitution? You know, since the question is in form of the square root of a square minus x square, if you make x a sine theta, meaning you'll be substituting a sine theta in place of this x, which will be giving you the square root of a square minus a sine theta all square, because there's square on the x, which is the same thing as the square root of a square minus a square sine square theta, okay. And then from this, it will be very easy to eliminate this square root. In what sense? If I factorize what is in the bracket, I have it to be the square root of a square into bracket 1 minus sine square theta, which is the same thing as the square root of a square cos square theta. Now at this point, I can eliminate the square root by saying it's the same thing as a cos theta. So we are including the constant a to our trig substitution so that it will be very easy to remove the square root in it, and it will be very easy to integrate. So that's what we call integration of trigonometry substitution, okay. Now let's try to solve a question, then we move on. Let's try to solve questions on that, okay. What if you have a question like, okay, now let's look at this question. Sorry, let's look at this question. We are given the integral of example, integrate from 0 to a, integrate the square root of a square minus x square dx. This question is from previous past questions, okay. Now to solve this particular question, seen from the format, it is of the form substitution of x is equal to a sine theta. So I can say that let x is equal to a sine theta, which if I differentiate that, I will have dx d theta to be equal to a cos theta. Therefore, dx is the same thing as a cos theta d theta, okay. And since I've gotten that, I can now work with my boundary. I'm trying to move the question from with respect to x, I'm taking it to with respect to theta. Then I have to change the boundary because this lower boundary this lower and upper boundary are with respect to x. But if I'm to take this substitution, in replace of the x, I'll be having the theta. Now, I've changed the question from with respect to x to with respect to theta. So this boundary is not valid for with respect to theta because the boundary is for with respect to x. So what am I going to do? We have what we call change of limit, okay? Now, you deal with your limit by saying, okay, change of limit, change of limit, okay? So let's start with the upper boundary. Now let's start with the upper boundary. When the upper boundary is a, that's when x is equal to a, comma, then from this substitution, yeah, we can say that a is equal to a sine theta. So when you make theta the subject of the formula, we have sine theta is equal to what? 1, okay? Therefore, theta will be what? Theta will be pi over 2. That's for the upper boundary. And then for the lower boundary, when x is equal to 0, we have is 0 to be a sine theta, which means theta will be what? Is 0 when you make theta the subject of the formula. Okay, so that's our what? Lower boundary and upper boundary with respect to what? Theta. Now let's write our question back. Writing our question back, we have the initial question will now be the same thing as the integral of the lower boundary is 0, the lower boundary is 0, that's 0. When the upper boundary is a in terms of x, the upper boundary is pi over 2 in terms of what? Theta, that's pi over 2, the square root of a square minus x square. What is x? X is a sine theta, that's a sine theta all square, which is the same thing as a square sine square theta, okay? Dx, what is dx? Dx is the same thing as a cos theta d theta, that's times a cos theta d theta. Okay, so this is what we want to integrate. Now we've been able to what? Change the question from with respect to x to with respect to what? Theta. Okay, but don't forget, we can factorize what is here. We can factorize what is here, right? We can factorize it as a square into bracket 1 minus sine square theta, right? Yes, that's correct. And we also recall that 1 minus sine square theta is the same thing as 1 minus sine square theta is the same thing as cos square theta, right? Therefore, I can say everything inside this place is the same thing as a square cos square theta. Okay, now let's continue solving. I can say this question now is the same thing as the integral from 0 to pi over 2, the square root of, after simplifying what is in the square root, that's what? A square cos square theta times a cos theta d theta, a cos theta d theta, which is the same thing as the integral from 0 to pi over 2. What is the square root of a square? That's what? A. And what is the square root of cos square theta? That's cos theta, okay? Multiplying a cos theta d theta. So I have it to be the same thing as a square integral is 0 to pi over 2 cos square theta d theta. Okay, so to integrate this, that will give us x square integral is 0 to pi over 2. You know, from our standard techniques, the integral of cos square theta is the same thing as theta over 2 plus sine 2 theta over 2. Yeah, we know that from our previous classes, but to make life very easy for those that are just joining us, we can say what is here is the same thing as 1 over 2 into bracket theta plus sine 1 over 2, sorry, I can say what is there is the same thing as 1/2 into bracket 1 plus sine into bracket 1 plus cos 2 theta d theta. So now let's integrate that. This 1/2 is a constant. Bringing it out, I have it to be a square over 2 into bracket. When I integrate 1, I have it to be what? Theta, plus when I integrate cos 2 theta, I have it to be sine 2 theta over 2. Okay, then we have our boundary. That's from pi over 2 to 0. That's pi over 2 to is 0. I'll be from 0 to pi over 2. Now when I substitute by definite integral, I have it to be a square over 2 into bracket. When I substitute upper boundary for this, I have it to be pi over 2 plus, when I substitute pi over 2 here, that will give us sine pi. And sine pi is what? Is 0. So that's 0. Okay. Minus, if I substitute 0 as lower boundary, I have it to be 0. When I substitute 0 here, I have it to be what? Is 0. Okay. Then that's the same thing as a square pi over 4. Or I say that pi a square over 4. Final answer. So that's the solution to that particular question. Okay, now in our next video we'll be looking at more questions on integration of trigonometry by substitution, by trig substitution.